Every app needs a backend, authentication, a database, file storage, serverless functions, real-time sync. You could build all of that yourself, or you could use a Backend-as-a-Service and have it running in an afternoon. Two platforms dominate this space right now: Firebase, Google's managed ecosystem, and Supabase, the open source challenger built on Postgres. They solve the same problem, but they solve it in completely different ways. Firebase stores your data as documents, JSON-like objects that you throw into collections. No schema, no structure, just push data and go. It's incredibly fast for prototyping. Supabase gives you a full PostgreSQL database. Tables, rows, columns, foreign keys, SQL, the same database engine that powers Instagram, Spotify, and half of Silicon Valley. One is flexible, the other is structured, and that single architectural decision changes everything downstream. How you query data, how you secure it, how you scale, how much you pay, and how easy it is to leave. So let's break it all down. Supabase is what happens when you take Postgres and wrap it in a modern developer experience. Every project gets a dedicated Postgres database. Around it, Supabase runs a stack of open source tools. Postgres auto-generates a REST API from your database schema. GoThrough handles authentication. An Elixir-based real-time server streams database changes over WebSockets. And demo-powered edge functions give you serverless compute at the edge. The entire stack is open source. You can see every line of code on GitHub. You can self-host it with Docker, and if you ever want to leave, you run pgdump and take your entire database with you. Standard Postgres, no lock-in. Security is where Supabase gets really interesting. It uses something called Row Level Security, RLS. Instead of writing security rules in a separate language, you write security policies directly in SQL, attached to every single table. And here's why that matters. Every query that touches your database, whether it comes from your app, a cron job, a migration script, or a direct SQL connection, passes through the exact same security check. There's no backdoor, no bypass. That makes it structurally harder to accidentally expose data. And for multi-tenant SaaS apps, where tenant A should never see tenant B data, that's a massive advantage. Supabase also happens to be one of the best platforms for building AI applications right now, because Postgres has an extension called pgVector. It lets you store vector embeddings, the backbone of semantic search and RAG, right next to your regular application data. Same database, same queries. You can combine keyword search, vector similarity search, and relational filters in a single SQL query. For teams building with AI, that's a huge architectural simplification. No external vector database, no syncing, just Postgres. Firebase is Google's all-in-one app platform. It bundles a massive collection of managed services under a single SDK. Firestore for your database, Firebase Auth for authentication, cloud storage for files, cloud functions for serverless logic, plus analytics, crash reporting, remote config, A/B testing, push notifications. It's a complete toolkit. Everything runs on Google Cloud infrastructure, and the client SDKs are deeply optimized for mobile. Years of production hardening on iOS and Android. But the real reason developers choose Firebase is offline-first capabilities. Firestore's client SDKs automatically cache data on the device. If a user loses their internet connection, the app keeps working. Reads and writes execute locally. When the connection comes back, Firestore syncs everything automatically and handles conflict resolution. For apps that operate in environments with unreliable connectivity, mobile field service, healthcare, logistics, this is not just a nice feature, it's a hard requirement. And Supabase has no built-in equivalent. Firebase's real-time engine is also mature and powerful. Firestore listeners keep query results synchronized in real time. You get offline caching, latency compensation, and automatic sync across devices. If you're building collaborative tools, multiplayer games, live auctions, or chat applications, Firebase's real-time system is battle-tested at massive scale. Sub 50 millisecond latency for most operations. Millions of concurrent connections handled automatically by Google's infrastructure. But Firebase's document model comes with a trade-off every developer should understand. There are no joins. If your data has relationships, and almost all data does, you have to denormalize it, duplicate it across documents, and then keep all those copies consistent yourself. Developers call this index hell. Update a user's name? You might have to update it in 50 different documents where it was copied. That's 50 write operations, 50 chances for something to go wrong. Firebase also has a quirk that catches people off guard. Security rules are not filters. If a client sends a query that could potentially return documents they don't have access to, Firestore rejects the entire request, not just the unauthorized documents. The whole query fails, which means you sometimes have to restructure your data model just to make secure queries possible. Authentication. Both platforms support email, social login, magic links, and multi-factor auth. Both offer 50,000 free monthly active users, but the security model is fundamentally different. Supabase enforces access control at the database level. Every query, every path, no exceptions. Firebase enforces security rules only on client SDK access. Back-end code using the admin SDK bypasses rules entirely. That's a meaningful gap. Enterprise SSO is also simpler on Supabase. Native SAML support on the team plan. Firebase requires upgrading to a separate product, Google Cloud Identity Platform, with its own pricing. Winner? Supabase. Structural security advantage. Database. This is where the philosophical divide hits hardest. SQL versus NoSQL. If your app has complex data relationships, reporting needs, or multi-tenant architectures, PostgreSQL wins. Full joins, subqueries, window functions, stored procedures, triggers, one query, one round trip. If your app is mobile first with offline requirements and unstructured data, Firestore's schemaless model lets you iterate fast without migrations. But here's a plot twist. In April 2025, Firebase launched Data Connect, a managed GraphQL layer on top of Cloud SQL Postgres. Firebase now has a relational database option. The SQL versus NoSQL divide is narrowing. Winner? Supabase for data-heavy apps, Firebase for offline-first mobile. Real-time. Firebase wins this category. More mature, more deeply integrated, native offline sync with automatic conflict resolution. If real-time collaboration is the core of your product, Firebase has a meaningful edge. Supabase Realtime is solid. It handles 10,000 plus concurrent connections and supports broadcast and user presence. For dashboards, notifications, and activity feeds, it works great, but it doesn't match Firestore's offline-first capabilities. Winner? Firebase, the real-time king. Serverless functions. Supabase edge functions run on Dino at the edge. V8 isolates instead of containers. Cold starts are virtually zero, around 50 milliseconds. Firebase cloud functions run on Google Cloud infrastructure, Node.js or Python. Rich trigger integration across the entire Firebase ecosystem. But cold starts. 500 milliseconds to 3 seconds. You can throw money at a problem with minimum instances, but that adds to your bill. Verdict: Supabase for speed, Firebase for ecosystem triggers. AI and vector search. This category has changed dramatically. Supabase keeps vector embeddings in the same Postgres database as your application data. One SQL query for semantic search plus relational filters plus full-text search. For RAG workflows, that's a massive simplification. Firebase has caught up with vector support in Firestore via Vertex AI, and Data Connect also uses pgVector under the hood. Plus, Firebase offers tight Gemini integration through Firebase AI logic and GenKit. Winner, Supabase for native vector search, Firebase for Gemini and Google AI integration. Now let's talk money, because this is where people get surprised. At 10,000 monthly active users with light usage, Supabase costs a flat $25 a month on Pro. Firebase can range from $0 to $15, mostly within free quotas. At 100,000 MAUs, Supabase is still around $25 to $75. Firebase jumps to $50 to $200 depending on read and write volume. At 1 million MAUs, things get interesting. Supabase runs about $3,000 to $4,000 a month, primarily driven by authentication overages. Firebase? $2,000 to over $10,000, and the variance is enormous because Firestore bills per operation. The hidden cost on Supabase is bandwidth and auth overages. Predictable, you can model it. The hidden cost on Firebase is read amplification, poorly optimized query, an infinite re-render loop, a real-time listener that churns. These can generate millions of reads in hours, and Firestore has no cost ceiling unless you set budget alerts. There's also a 2026 gotcha. As of February this year, Firebase Cloud Storage requires a billing account, even for the free tier. The completely free forever narrative for Firebase storage is officially over. Vendor lock-in. This one's straightforward. Migrating away from Supabase means running pgdump, standard Postgres backup, imported into AWS RDS, Google Cloud SQL, Railway, Neon, or your own server. Your RLS policies, stored procedures, triggers, all standard SQL. They come with you. Migrating away from Firebase means restructuring your entire data model, converting the normalized NoSQL documents into relational schemas, rewriting your security rules from scratch, replacing every Firebase SDK call in your client code. It can take weeks. Firebase Data Connect helps if you used it from the start, but for Firestore-based apps, migration is genuinely painful. So here's the honest recommendation. Choose Supabase when your app has complex data relationships, when you need SQL, when you want predictable billing, when you're building AI features with vector search, when you need to self-host or avoid vendor lock-in, when your team knows Postgres. Choose Firebase when you're building offline-first mobile apps, when real-time sync is your core feature, when you want the deepest iOS and Android SDK support, when you're already in the Google Cloud ecosystem, when you need analytics, crash reporting, and push notifications in one toolkit. But here's the interesting thing about 2026. The gap is closing. Firebase now has a Postgres option through Data Connect. Supabase keeps improving its real-time and mobile story. They're converging. The real question isn't which platform is better. It's which philosophy fits your project. Own your data layer with Supabase, or let Google manage everything with Firebase. The answer to that question should guide your decision. If this breakdown helped you decide, subscribe. More showdowns and deep dives are coming. I'll see you in the next one.